today we start the second portion of the last unit here, where we're talking about volume instead of surface area, and we're specifically looking at, and just like we did with surface area, we're going to break it up into shapes. So we're specifically looking at prisms and cylinders today. Now, surface area deals with the amount of visible space on an object, so like how much you can see of this figure. You're finding the area of all of those sides. Volume, on the other hand, so that's what we're doing today, volume deals with the amount of occupied space that an object takes up. So that's the big thing. It's how much space an object occupies or takes up. Now, it doesn't matter if you can like see every surface, it's just how much space it occupies. Now, the way that you write volume, it's given in cubic units. Area was always like inches squared, meters squared, because that was how many little like 1 by 1 inch, centimeter, whatever units you're talking about. It was how many little squares could fit on a figure. Volume is cubed, inches cubed, meters cubed, because it's how many little cubes can fit inside a figure. Now, we'll do prisms to start here. To find the volume of a prism, the formula is pretty simple. You just need to find the area of the base, just one of them, and then you multiply it by the height of the prism. So the formula looks super straightforward. It's just big B times H, the area of the base times the height, but it will get a little shaky depending on what kind of prism you're looking at. So there's two notes that I'm going to make on here. I'm going to say about big B that finding big B will vary. All right, so if it's a hexagon, the base, obviously you'll use 1/2 AP. If it's a triangle, that will determine what formula you use for big B, so big B is going to vary. Also remember that in a prism, the bases are the two congruent parallel faces. Okay, so maybe that's the tricky part for some of you, actually picking out which piece the base is. Some of you still struggle with finding the height. The height is the piece that connects the bases. All right, so it could not hurt to really emphasize these last two bullet points here. Because if you can't pick out the right base for the base and you cannot pick out the right piece for the height, you're never going to get these right. Okay, so be really careful. If I look at example 1, this is a triangular prism. Okay, the bases are the two congruent parallel faces. Basically, you guys, the bases are the non-rectangle pieces. We've been saying that for a while now. So those are the bases. To calculate the volume, I need to find big B times the height. So the base is a triangle this time, so I'm going to use 1/2 base times height. And let's see, that's going to be 1/2 times 7 times 8. It's a right triangle, so that's pretty straightforward here. So 28 is big B. So then when I find the volume, I just do big B, area of the base, times the height of the prism, and the height's going to be the piece that connects the two triangular bases, which is 13. So my volume is 364. They didn't tell me the units, so I'm just going to say units cubed. It would help if you could see that. All right, so that's how many little cubes can fit inside of this prism, 364. That's how much space it takes up. For example 2, this prism is made up of trapezoid bases, which is kind of weird. We haven't seen one like this before. Okay, so that trapezoid and the one opposite of it would be the bases, would be the non-rectangular pieces, two congruent parallel ones. All right, so to calculate the area of that trapezoid, I got to go back and remember what the formula looks like, which it's on your formula sheet under the area section, but that's the area of a trapezoid. We'll throw back here. Base 1 and base 2, those are the two parallel sides on your trapezoid. So that's going to be 14 and 8. Doesn't matter which one's which. And the height of the trapezoid is 4. Okay, so if I just plug all that into my calculator, the area of the trapezoid is 44. Big B is the hard part, so once I've got the area of the base, I'm going to multiply that by the height of the prism, not the height of the base, the trapezoid. The height of the prism, remember, that's the piece that connects the bases. So that's going to be that 10 right there. All right, so the volume would be 440 cubic centimeters. All right, on the back we got 2 more examples of prisms, and notice how much space was left for cylinders. So obviously prisms are a little bit more challenging than cylinders here. Need more practice. For example 3, this is a hexagonal prism, and they want me to write it in simplest radical form. So think factor trees. Now, big B, always the hard part. The bases, they're hexagons this time, non-rectangular faces. So I know I need to use 1/2 AP to calculate the area of a hexagon. All right, let's get a little picture going. There's the apothem. Be right here on my actual prism. So half of one of the sides would be 3. Remember, we always have to find the angle. So we do 360 divided by how many sides there are. We cut that in half. So this angle is 30 degrees. Simplest radical is your hint that you need to use special right triangles, 30, 60, 90s. So the short leg is 3. The long leg would be 3 radical 3. Multiply by radical 3 to get the long leg. So that's the apothem. And the perimeter of just the hexagon, each side is 6, and there's 6 sides. So the perimeter would be 36. Do not put the radical 3 in your calculator. Just put everything else in there. And that would be 54 radical 3 for big B. So then when I go to find the volume, area of the base was 54 radical 3, and then go back to the prism times the height, which is going to be the piece that connects the hexagons, which is that 15 right there. So same thing, don't put the radical 3 in your calculator, multiply everything else, just stick the radical 3 on the end, so it'd be 810 radical 3 units cubed. All right, last prism, and this one is a composite figure. So there's 2 shapes in one, and here is what we're gonna do. We're gonna break it up into the bottom prism, so kind of like ignore the fact that there's a point on it. Let's just think of that as the rectangular prism. So I always pick out the 2 shapes first. So there's a rectangular prism, and on the top, that's a triangular prism. Okay, so it's always helpful if you kind of break it up first, find both volumes, and then add them together. So let's do the rectangular prism first. So big B. You guys, if every single face on your prism is a rectangle, it doesn't matter which sides you pick to be the bases. Doesn't matter, just pick a pair of opposite faces. Most of us would gravitate towards the top and the bottom as being the bases. Okay, so it's just a rectangle, so the area of the base would just be 8 times 5, which would be 40. So the volume, I would take the area of the base times the height of the prism, which would be the piece that connects the top and the bottom, or 6. And that would give me 240 for the rectangular prism. Now let's shift gears and look at just the top part, the triangular prism. When you go to find big B on this one, not all of the faces are rectangles, so it does matter which pieces are your bases, and that's going to be the triangles on the end here. Those are the bases. Okay, let's draw one over here. They're marking them isosceles, which is kind of weird. Ooh, they also told me that this was 4. So that's 4. And this, if I bring the 8 up, that's 8. The fact that it's isosceles would make that a right angle, because it's like cutting it straight in half. Now, I can find the area of this. So it's a triangle, my base, so I got to use half base times height. And if that's a right angle, I can just do half times 8 times 4. So big B is 16. To calculate the volume, I would do big B, area of the base, times the height of the prism, which again, that's going to be the piece that connects the two bases. So it's got to be the piece that connects the triangles, which is 5. So that area is 80. Now I just want to add the two areas together, and the combined, sorry, not areas, volumes. I want to combine the two volumes, and the total volume of this crazy shape is 320 centimeters cubed. All right, so prisms take a little bit of thought just because you got to find that big B, area of the base, and you got to pick out the bases. Now, in a cylinder, it's a lot more straightforward. Remember that a cylinder is almost the same as a prism, except that the base is not a polygon. So it's not going to be a triangle, hexagon, octagon, whatever. The base is always a circle. So this one is a lot more consistent. Like I said, you don't have to think as hard because big B does not vary. So the volume of a cylinder, it's still the same concept as for a prism. It's the area of the base times the height. But since the base is always a circle, instead of putting big B, we put pi r squared, because that's the area of a circle. And you multiply that by the height. So all you need is the radius and the height. Make sure you just watch out for how they want you to write it. They want this one in terms of pi. This cylinder, you guys, is called an oblique cylinder. It's kind of like slanted a little bit, but everything's still there. The radius they're trying to show you is 5. When they draw the height in, it's got to be perpendicular to kind of like the ground, if you want to think of it like that. So that's kind of why the height is like way out here outside of the shape, because it's got to make a right angle with the ground. So don't think of this as a triangle. Ignore this little piece right here. That's irrelevant. The radius is just 5, and the height is 15. So you just got to plug it in. So pi r squared times the height. And I'm going to leave it in terms of pi, so don't put pi in your calculator. It'd be 375, stick the pi back on, centimeters cubed.